Question 4. Jason is at window 10 meters above the ground. Kamal is on the ground directly below the window, holding a tennis ball. Kamal throws the ball vertically upward to Jason. The height of the ball, h, is given by h is equal to ut minus 4.9 t squared, where u is the speed at which Kamal throws the ball in meter per second, and t is the time in second after which the ball has been thrown. Let's say this is the ground. This is the window. And the window is 10 meters above the ground. So Jason is over here. And Kamal is over here. And Kamal throws the ball vertically upwards to Jason. We are given the equation for the height of the ball h. We can sketch the curve. X-axis will be the time, and y-axis will be the height of the ball. Because our x-axis is our time, hence we do not have any negative value. We have a negative a square, hence the curve should look like this. When Kamal starts throwing the ball, it will go up until the maximum height. If Jason not managed to catch it, the ball will drop back to the ground. A. Find the minimum value of u for which Jason can catch the ball. We are asked to find the smallest u in order for Jason to catch the ball. Jason is 10 meters above the ground. Therefore, the smallest maximum height must be 10. We have the height of the ball, h is equal to ut minus 4.9 t squared. This is our first equation. And we need the height to be 10. This is our second equation. Since both equations have the same subject, equation 1 is equal to equation 2. ut minus 4.9 t squared is equal to 10. We rearrange the equation into general form. In order to obtain a positive a square, I will bring all the terms to the right side. 4.9 t squared minus ut plus 10 is equal to 0. Since 10 is our maximum value, that means the line h equals to 10 touches the curve ut minus 4.9 t squared. And we get the discriminant is equal to 0. Our a is 4.9. B is negative u, and C is 10. We substitute the values of A, B, and C into the discriminant and let it be 0. Negative u squared minus 4 times 4.9 times 10 is equal to 0. We simplify the equation. U squared minus 196 is equal to 0. U squared is equal to 196. We square root both sides. U is equal to plus minus square root of 196. And U is equal to plus minus 14. In this case, we will get the positive value for U. Hence, the complete equation for our H will be 14t minus 4.9 t squared. B. Find the time of flight if Jason does catch the ball when it is thrown at this speed. That means when h is equal to 10, what is the time? 10 is equal to 14t minus 4.9t squared. 4.9t squared minus 14t plus 10 is equal to 0. So it is actually the same thing from here. And now we need to solve for our t. For this question, this equation is a quadratic equation. We can do factorization, completing the square, or use formula to solve for our t. For this question, I will do it using formula. As what we get from part A is 4.9, B is negative 14, and C is a 10. Our t is equal to negative b plus minus square root b squared minus 4ac over 2a. We simplify the equation. We get 14 plus minus square root of 0 over 9.8. Therefore, t is equal to 14 over 9.8. We simplify it and it is 10 over 7 seconds. Question 5. A fish is moving in a circular manner with the equation of its locus being 2x squared plus 11y squared plus 2x plus 2y is equal to 0. A boat is moving along a straight line of equations x minus 3y plus 1 is equal to 0, and it intersects with the circular locus of the fish. Find the points of intersection between the locus of the fish and the trajectory of the boat. The fish is moving in a circular manner, and the boat is moving along a straight line. Hence, this point and this point are the points of intersection between the locus of the fish and the trajectory of the boat. We are given two equations. The first one, the motion of the fish, 2x squared plus 11y squared plus 2x plus 2y is equal to 0. And the second equation, the trajectory of the boat, x minus 3y plus 1 is equal to 0. For this equation, I will make x our subject. X is equal to 3y minus 1. And we let it be equation number 2. In order to solve for this simultaneous equation, we substitute equation 2 into equation 1. 2 multiplied with 3y minus 1 square plus 11y square plus 2 multiplied with 3y minus 1 plus 2y is equal to 0. We expand the bracket. 2 multiplied with 9y square minus 6y plus 1 plus 11y square plus 6y minus 2 plus 2y is equal to 0. We expand the bracket again. We will get 18y square minus 12y plus 2 plus 11y square plus 6y minus 2 plus 2y is equal to 0. We simplify the equation. 18y square plus 11y square, we will get 29y square. Minus 12y plus 6y plus 2y, we get minus 4y. Plus 2 minus 2 is gone, and the equation is equal to 0. We factorize the y outside. Y multiplied by 29y minus 4 is equal to 0. Hence, y is equal to 0, or 29y minus 4 is equal to 0. 29y will be equal to 4. Y is 4 over 29. Then we substitute the values of y into equation 1 or 2 to obtain our x. Here I will choose to substitute into equation 2. X is equal to 3 multiplied with 0 minus 1. X is equal to negative 1. Therefore, the first point of intersection is -1, 0. We do the same thing for y equals to 4 over 29. We substitute y equals to 4 over 29 into equation 2. X is equal to 3 multiplied with 4 over 29 minus 1. We simplify it. 12 minus 29 over 29. And we get our x is -17 over 29. Hence, the second point of intersection is -17 over 29, 4 over 29.